So Mrs. Outgravy and I decided that we think having a day of combining 3.6 and 3.7 would be a good thing, just to get more practice for one, but also to see them together because they are very much related, dealing with this coordinate plane and the slope and making sure we're good with that.
And hopefully you guys tried them first because this is just a review of the last 2 days. But we're going to go ahead and talk you through them so that way hopefully you can just make sure that you're on the right track.
Exactly. All right, so the first couple questions are going to ask you, are the lines parallel? So we have two lines in this picture. Notice that they already are graphed for you, so that could mean two different things. We could actually find the slope by using the slope formula, or we could count. And again, if you're asked, are they parallel?
We're looking at their slopes.
We're looking at the slope because
are the slopes the same?
The whole thing is, are the slopes the same? Okay, so we're finding the slope. Let me maybe call these lines. Yeah, I know.
What about A and B?
Good idea. Okay, so let's find the slope of line A first.
Okay, and I'm going to go ahead and count them because it's easy enough to count when they're on that coordinate plane.
I like that idea. And you said you like to start with the left.
I do like to start with the left.
So she's starting at -2, 3, and then she's going to work our way to 0, -3. So counting from there, which direction are you going to go first?
I'm going to go down first, so it's negative. So down 1, 2, 3, 4, 5, 6. So -6, that's my down 6, and over 2.
So over meaning to the
right, so
right
positive.
2, +2. So that simplifies to
-3.
All right, let's do B.
Line B. Okay, that one, it looks like we're going down, let's see, 1, 2, 3, 4, 5. Down 5 would be a -5 over 2. Ooh, this is kind of tricky. They kind of look to be almost parallel.
They did.
They're pretty close, but not the same slopes. They're not parallel. They would eventually cross.
This would be no. Are the lines parallel? No. Doesn't say explain, but if you had to, you would say because the slopes are not the same. Either way. And again, I like how you said they kind of looked parallel.
Yeah.
So it's kind of deceiving. Don't
can't
base it off
assume
what it looks like. You got to support it by actually finding those things. All right, so Ms. Hochgrabe, do another one for me.
Now, this one's talking about perpendicular. So we're, again, trying to determine if the lines are perpendicular. We still need to look at their what?
Slopes.
Their slopes. So let's find the slopes. And they don't have names on these either. I'm going to call them P for Palermo and H for Hochgrabe. How about that one? Okay.
Perfect.
So let's start with line P. Help me find that slope. Do you want to count? What do you want to do?
Let's count.
Okay.
I like to do that, especially since it's in the coordinate plane. So I'm going to start with the left. Now, there's like 3 points I can pick. Can I pick like the one that they're intersected with?
Sure.
It's closer to that other one.
That sounds great.
So
it's still
you don't have
labeled
to,
as a point.
So I'm going to go from here, the 3, 7, and I'm going to count. I'm going to go down 1, so -1, and then I'm going to the right 1, 2, 3. So that means I don't even have to simplify.
Exactly. And if I had chosen that other point, that 9, 5, I would have a fraction that would just simplify to be -1/3. Or, yeah, -1/3.
I think it would have gone down 2 and to the right 6, which simplifies to -1/3.
So let's take a look at line H. Let's find its slope.
Okay, so line H, let's start with the intersection point first.
Okay.
And I'm going to go up to the 7, 8. So I'm going to go up 1, 2, and to the right 1.
All right. So
All
conclusion,
right, so
what do you
decide
think?
if the lines are perpendicular, I can think two different things. Since there's no explanation, I'm just going to think the opposite reciprocal idea. And they are opposite. One's positive, one negative, but they're not reciprocal. So that would be a no. They're not perpendicular.
Not perpendicular.
And they kind of look like it.
Again, and we purposefully did some right now where they look close to it, but they're not, because we have several people that will want to think, oh, yeah, they should be. I must have miscounted.
Yeah.
Don't assume you miscounted.
So you have to have some kind of support. You don't have to show the slope formula. Just doing like the counting, that kind of works when the graph's already there. All right.
Now, if the graph's not there,
we want the slope
formula.
Perfect. All right. Another question. We're going to write some equations, get more practice with that, of a line that is parallel. So a key word. Okay, we're writing an equation of a line that's parallel. So what are we going to be thinking when I see the word parallel?
I'm thinking same slopes.
Okay. And it's to the given line that passes through the given point. So it's parallel to this. So the only thing that really matters in that equation is the slope. And what is the slope of that line?
That slope's -1.
Think of that kind of right in front of that. and we know this is the point. Now, you said same slope, so this is the slope, and this is the point. What are we going to use?
I'm going to use point slope form because
I've
got a point and I've got a slope.
All right, so point slope form, so it would be y.
Minus a negative 2 will be a y plus 2 is equal to that slope, so negative 1 times the quantity of x minus a negative 4 would be a plus 4.
So again, this is like your x1, y1. Perfect, and then we're going to go ahead and
turn that into slope-intercept form. So I've still got my y plus 2, but it's going to equal that negative 1x or negative x, either way that you want to write that.
I might actually write negative x because that's usually what the book will have. That's what I do too.
And a negative 1 times 4 would be a negative 4, so minus 4. And then we're going to go ahead and subtract our 2 from both sides, so y equals a negative x minus 6.
And you're done because you've written the equation in slope-intercept form, which is what they want in the end.
And it's always kind of good to just double check. Are those lines parallel? Yeah, they have the same slope, and they should have different y-intercepts, or else they'd be the exact same line. So it's kind of a good thing to double check. All right. This next one says we're going to write an equation of a line, but now it's going to be perpendicular to the given line, and it passes through that given point. So we want something to be perpendicular to this line. What am I thinking when I know I need something with perpendicular? What's our key thing?
Well, since I'm not having to explain anything, I'm going to be thinking opposite reciprocal slope.
Sounds great. So what is the slope?
Well, the slope of the original one is 2/3.
So what
but
is...
it's not the same, so I'm going to use the perpendicular slope, which is a negative 3/2.
Wonderful. And that's exactly right. And I love that you emphasize that too. I don't want to use the original line. I want that perpendicular slope because I want a perpendicular line. So make sure you first find that perpendicular slope, then we can write our equation with this new perpendicular slope. Okay, so we've got a slope and we've got a given point that that line passes through.
Let's do point slope.
I think that sounds great. Okay, so what are we going to do?
So it'd be y plus 2 equals a negative 3/2 times the quantity x minus 6.
And we're not going to leave it like that.
Distribute, so it'd be y plus 2 is equal to negative 3/2 x plus 9, because it's a negative times a negative. And then subtract 2 on each side, and you get y equals a negative 3/2 x plus 7. And you're done.
And that is our equation of a line. They're perpendicular, and if you look at their slopes, they are opposite reciprocals. They have a product of -1, and really y-intercept doesn't even matter on those.
No, it does not. They could be the same, actually. Another question, it says, are these lines parallel, perpendicular, or neither? Okay, so this one has multiple pieces to it.
Okay.
I'm
looking at I need to know their slopes, though. When I'm looking at those lines, they're in standard form.
If they're talking about parallel and perpendicular, and you're talking about kind of more coordinate, I know it's not graphed, but they're talking about linear equations, you're going to be thinking slopes. And the only way you can do it is if they're in what form?
Slope-intercept form.
All right, so let's call this the first one. This is the second one. So the first one, 7x plus 2y, maybe, equals 5. Let's get in slope-intercept form. What would you do first?
Okay, so subtract that 7x. So 2y will equal a negative 7x plus 5. And then divide everything by 2. So y equals a negative 7 over 2x plus 5/2.
And really the only thing that matters here is its slope. So this little guy right here is all we're going to look at.
Okay.
All right, so the second one.
So the second equation, we had our 2x minus 7y equals 5. And if I go ahead and subtract my 2x from both sides, negative 7y would equal a negative 2x plus 5. And then divide everything by that negative 7, so y would equal a positive 2/7 x minus 5/7. All right, I'm looking at those slopes. One has a negative 7 over 2, one's a 2 over 7. And those are opposite and reciprocals, so these are perpendicular lines.
And is it okay if I just use that symbol, perpendicular?
Sure. Now, I'm looking at this, and it doesn't say to explain.
But what if it did? What would you say?
If it said to explain, I would need to show that negative 7 over 2 times a 2 over 7 should equal a -1, which it does.
Now, if it says explain, does that mean showing?
Well, that's just the work.
Okay.
But then knowing that, I could say that they're They are perpendicular because the product of their slopes would equal negative
And
1.
and Miss Hoker even said it. She said showing. So this is more showing. Explaining would be in words, and it would be saying that the product
Equals negative
of slopes is equal to -1. Perfect.
All right. Now this one says, are these lines parallel, perpendicular, or neither? So same task. We have two lines. Right now they're both in what form?
Standard.
And that's not necessarily very helpful. So let's turn these equations again into slope-intercept form. So starting with that 2x minus 5y equals 8, what can we do?
I'm going to subtract 2x, so -5y equals a -2x plus 8. Divide everything by -5, so y equals, and positive 2/5 x minus 8/5. So I'm just looking at that slope. Remember that. My second one is going to be 5x minus 2y equals 2. So I'm going to subtract 5x, so -2y equals a -5x plus 2. Divide by -2, so y equals 5/2 x minus 1.
Okay.
So the slopes is where I'm looking.
Exactly.
And I notice they're not the same, so they're not parallel. They are reciprocals but not opposite, which means that they're not perpendicular, so neither.
Exactly. And I love that you kind of just reason that with yourself. They're not parallel, they're not perpendicular, so then my only other choice is neither. And that's exactly what I want you guys to be thinking. Look at their slopes. Are they the same? If not, okay, are they opposite reciprocals? Is their product -1? And if not, then you're kind of in that neither situation.
Process of elimination a little bit. I think we have one more example. Yeah, the last one. It says determine if the intersection of line AB and line CD forms a right angle. Okay, so we're trying to see if obviously we're not like going to actually graph this. We're deciding if they're going to form a right angle. It does say explain, so we're going to have to talk about like what that basically means. Now, if I'm trying to decide if two lines intersect to form a right angle, we essentially are deciding if the two lines are
perpendicular.
Really, this is the real question. Yeah. So if we can decide if they're perpendicular or not, then we can decide if they form a right angle or not.
Makes perfect sense.
So perpendicular would mean right angle. If they're not perpendicular, it means they don't form a right angle. So you kind of get that idea. Now, the only way we can decide if they're perpendicular or not, like in solid way, without just kind of eyeballing it, is to
find their slopes.
So that's kind of essentially our first task. So I have 4 different points. Do I need to find the slope between all of like the points, like AB and then line AC?
Well, yeah. No, I don't, because I'm really just looking to see if AB and CD form a right angle. So I need to find the slope of AB and the slope of CD.
So notice I'm just going to label that. So I'm going to do AB and then line CD. I'm going to find the slope of each of those. So since it's not graph for us, we're going to use the
slope formula.
All right, so let's do line AB first.
Okay, so there I'm going to take 6 minus 8 over 1 minus 5. And that's going to give me a -2 over a -4, which would be 1/2.
All right. Line CD.
I'm going to take a 5 plus 3, because it's that minus negative, and -3 minus 1. And that's going to give me an 8 over a -4, which would be a -2.
Okay, so we haven't answered the question, but this is going to help us out. And it does say explain your answer or your reasoning in a little bit. So let's first answer the question. Determine if the intersection of line AB and line CD forms a right angle. So, are these going to form a right angle?
Well, yeah, they are. Because I know that just by looking at it, I can tell they are opposite reciprocals.
Okay.
I can show my work to show that their product does equal -1.
So if I multiply multiply the slopes, it ends up being -1. So let's explain it. Okay, so let's think about first of all what the slopes first tell us.
Okay, so I could say the product of their slopes is -1.
So I'm going to put product of slopes. I'm going to put equals -1 if you're cool with that. Which basically means means what?
Which means that they are perpendicular. Okay. But really, that's not what they asked me either, is it? They asked if it forms a right angle. But when we have lines that are perpendicular, by definition, that means that they are forming a right angle. So
Okay, so let's go back. So I'm saying yes. Product of slopes is -1, which means line AB is perpendicular to line CD. So then what do you want me to say next?
then let's say that
Or therefore? Or...
therefore, yeah, that sounds good. Therefore, they form a right angle. Do I need to be more specific, or is that okay? Therefore, the lines form a right angle, maybe. Form a right angle
By
definition of perpendicular.
Yeah, perfect.
That was a little wordier just because that's technically not what the theorem states. So I needed to really use a couple ideas to get there.
It was kind of a two-parter in a sense. You had to first determine if they're perpendicular or not, and then you had to then elaborate off of that. So if this was a no, let's say they did not end up being perpendicular, so their product of slopes is not -1, then you would say then they're not perpendicular, which means they don't form a right angle. Okay, so all of these things it's kind of that step-by-step type thing.